Okay, so I know it's getting ridiculous. How many 10-minute videos do I need to teach, a regular class period? Anyway, so it's an inside change, so it behaves opposite of what we think. It's going to be stretched. Flip that 1/2 upside down, stretches by 2. What that means is where the parent function was able to have a graph or a dot at 1, 1, okay, it did have a dot at 1, 1. Now it's going to take twice as much x-axis, okay, as it is to get the same y. So we have to go over 2 to get the 1. This point right here was the point 2, 2. That one became 2, 1. So what we did have a 2, 2 right here, we now need twice as much x-axis to get the same y value. We did have the point 3, 2. I'm sorry, it was 3, 3. We did have the point 3, 3 on here. And what did take, when we could get up to 3 just by going over 3, we now have to go over twice as much to get up to 3. So we have to go over to 6, 3. So we took the graph and we compressed it horizontally. We shoved it kind of out and down. Okay? So this number right here, you do the opposite of what it says to the x. So we don't multiply it by 1/2. We actually multiply each one of them by 2. And when it was the absolute value the other way, when we did this right here, where we did have a dot right there at 1, 1, it only took half as much x to get the same y value. We did have a point at 2, 2. It took half as much x-axis to get the same y value. Where we did have a point at 3, 3, it took half as much x-axis to get the same y value. Okay, where we did have a point at 4, 4, right there, we did have a point at 4, 4. The point was at 4, 4. It only took half as much x-axis to get the same y value. So we took each one of these and we divided it by 2. Instead of multiplying by 2, we multiplied by 1/2 or divided it by 2. Divided by 2, divided by 2, divided by 2. So we do the opposite of what you think. It says multiply by 2, so you divide by 2. Okay, it says multiply by 1/2, so if you multiply by 1/2, the opposite of that would be to divide by 1/2. Now remember, when you divide by fractions, what does that do? How do you divide? Good grief. How do you divide by 1/2? You remember how to divide by 1/2? Instead of dividing by 1/2, that becomes multiplication by keep your whatever you're changing, divide, change becomes multiply by 1/2, flip it upside down, keep, change, flip. So instead of dividing by 1/2, we multiply by 2. Okay, so that's how we do stretches. Let's see what else is left. This lesson has got to be coming to an end. It seems to be going on forever. Okay, so summarize it. If the number is greater than 1, what if it's a negative? I don't want to do it right there. I don't want to summarize right there. Okay, I guess I will. Let's just see what they say. No, I don't think I have it pulled up. Okay, so if K is, I can't write on that. Shoot. Let me copy and paste real quick. Move that out of the way. Copy and paste. Okay, so this is saying what happens when this number right here is 1. So when the K is a number bigger than 1, like 2, 3, 4, 5, we divide by that number. Divide by K, or multiply by 1 over k. Dividing by k and multiplying by 1 over k is the same thing, okay? And it is a compression in. So it is a horizontal compression. The x values are going to be changing by this much. That's what the x values are going to be changing by. What if it's a negative 1? Let the negative, if it's absolute value, that negative 1's not going to do anything. Because remember, if the absolute value looks like this, if we reflect this over here and we reflect this over here, nothing changes. So negative doesn't matter, doesn't change anything. What if it's a value between, when you see this right here, what do you think? You better think fraction, because that's all they're telling you it is. If it's a fraction. So what if k is a fraction? If k is a fraction, then you divide by the fraction or multiply by the reciprocal, k over 1. Okay, it's going to be a horizontal stretch, which means it's going to move the graph out this way, make it wider. It's stretching it horizontally, and all of the x values will be that much bigger to get the same y value. Now, you can't tell if that's a comma, can you? Okay. All right. So what do we have now? Some problems we can do. Okay, let's see if I can't copy and paste both of these. I should have already done this. I'm sorry. Copied and pasted. Should have already done that. I'm just eating up your time. Okay, so what's going to happen? Each graph shows a transformation g of x of the parent function. Describe the transformation. Okay, so we'll make these just a little bit bigger, so it'll be easier to see. Okay, so looks like we have, here's the absolute value, right? And it looks like it's gone in like this. The parent function has gone in. What are we doing? It's a compression. Okay, so that means, since it's a compression, that means my k is going to be greater than 1 because it's a compression. So how much did it compress? Where it was, it looks like a 3. It's now, because see, this is 1, 2, 3. This is the point 3, 3. 3, 3 changed to the point 1, 3. So what happened right there? We took what 3, 3 was originally, became a 1. So it looks like g of x we divided it by 3. 3 divided by 3 gives me 1. Oh, this one's so much easier. What did we do? All we had to do is go 1, 2, 3. Remember, 3 changes on the outside down. This is a vertical change. Okay, vertical changes happen where? Outside on the vertical changes. Plus, minus, it went down 3. So we need an outside change of 3. So an outside change of negative 3 should be what g of x equals. Whew, I hope we're getting close to the end. I'm tired. Where's my thing? Okay, read this example. They're doing 2 of them. It's a compression and a shift left. A shift left, and then they compressed it. They shifted it left, and then they compressed it. So read that example. Now we got to do these 2 right here. Oh, I'm going to run out of time and have to do another video. This is getting ridiculous. Copy. Yeah, I knew it. See? Ran out of time right there. Copy. Paste. But I feel confident that this last video will definitely be the last one.